So I'm Gavin Farrell, a PhD candidate at the University of Padua, a member of Elixir Italy, which is life science research data infrastructure. And I'll be presenting on Towards Reproducible AI, Research in the Life Sciences, Best Practices with Dome. So machine learning in the life sciences, why is it so significant? Well, in recent years, there's been a massive growth in machine learning application methods being applied to the grand challenges in the life sciences. Why has this been the case? Well, there's been a huge democratization and increase in access to powerful hardware, such as graphical processing units, and also a huge amount through the open science movement, increase in availability of high quality and fair biodata, which stands for findable, accessible, and interoperable and reproducible data. So this has led to landmark successes for life science challenges, which has then spurred on others to also take up and apply machine learning to further fields. One of the ones I want to highlight as a key application and one of the most well-known successes in life science machine learning is AlphaFold, which many people might have heard of, but maybe not. And this is used a machine learning model for predicting protein structure. Which has been a huge challenge in recent decades. And as we can see here, in every cell of your body, you have your genetic code, which then has a specific sequence of different letters, which codes for these protein strings. But this protein string of how it all folds together and makes the final protein structure, which does very elaborate tasks in the body. There was this challenge that you couldn't go from that sequence into having the final structure, but AlphaFold managed to solve this immense challenge, which was a huge success for life science machine learning. You might have seen if you were following the Nobel Prizes last year. So this is a press release from October 9th, 2024. They were awarded the folk here in the picture the Nobel Prize for Chemistry for their AlphaFold successes, which was a massive achievement and recognition of machine learning as potential in the life sciences field. Additionally, some other machine learning applications in the life sciences. Two key ones that I'd like to highlight is potential for drug discovery applications and bioimaging. So in the field of drug discovery, machine learning models are helping to support drug design and screening and also chemical synthesis. As you can see here, this is from a paper where machine learning is being applied to support the prediction of feasible reaction conditions for chemical synthesis using drug design. And as well, further down, you can see in bioimaging, machine learning models are being widely applied for improving diagnostics in clinical settings, such as cancer detection. This image here shows a breast cancer screening, and on the left, to the naked eye, you wouldn't be able to detect that there's cancerous growth, but using machine learning methods and bioimaging approaches, they were able to detect this cancerous growth and apply intervention. Additionally, the bioimaging folk have been very successful, securing lots of large European Commission funded grants, such as the AI for Life project by the Euro Bioimaging Research Infrastructure folk, which is doing immense work to build infrastructure in the space for bioimaging machine learning. So with all of this, there's been a corresponding boom in machine learning publishing growth. As you can see on the graph here, this is a keyword search of papers mentioning machine learning in the Europe PMC open access publications database. So it doesn't include every single potential paper out of there, but quite a huge amount. And year on year, out of the new papers that have been published with the term machine learning, you can see in 2024 alone, there was 85,000 approximately new papers mentioning machine learning. So there's been a huge exponential growth in machine learning publishing as a result of the applications being applied and machine learning being used in the life sciences. But with this comes a corresponding machine learning publishing crisis in the life sciences. And what the issue is that machine learning publications are producing very poorly described machine learning methods in these papers. And to put this into context, if you were to go into a store and if you were presented with, you wanted to buy a yogurt and there's two items in front of you, one has all of the details on it, the ingredients, the nutritional facts, the best before date, and the other has absolutely nothing on it at all. Which would you feel comfortable picking? And you'd look at some certain aspects such as the reproducibility, transparency, and trustworthiness of the product. And obviously you go for the better described one, but in the life sciences, there's no rules to mandate that all of these checks and balances are in place to describe them and make sure that we're having reproducible, transparent, and trustworthy machine learning publications. And further to this, why is this happening? Well, there's a twofold level for why the machine learning publications are coming out so poorly. Is there's challenges at the researcher level. For applying machine learning methods, you need a lot of cross-domain expertise and computational approaches, statistical approaches, and so on, as well as the domain expertise. Applying machine learning, there's no straightforward pathway to this. There's many routes you can go down, so that makes it difficult to follow a specific pathway and best practices. And then additionally, there's a lack of harmonized machine learning standards, for example, for publishing metadata on your machine learning model or your data set and so on, which is making it poor machine learning methods then percolating into the publications. Further, at the journal level, there's a lack of journal requirements to actually mandate certain standards are followed for the machine learning methods publications. And also the reviewers doing the peer review might be domain experts, but not machine learning experts, allowing a lot of poorly described or incorrect machine learning methods to slip through into the publications. So what have we done in Elixir Europe? Well, we have an expert group of machine learning experts called the Elixir Machine Learning Focus Group. Elixir, for context, is a European life sciences data research infrastructure, and it has over 250 research institutes across over 21 member states. They work together to provide bioinformatics infrastructure, such as life science data focused compute, databases, or training. And these expert working groups then exist within Elixir with members across the different member states. And the Elixir Machine Learning Focus Group members came together to address the life science machine learning publishing crisis. How did they actually do this? Well, they managed in 2021 to get this publication out. It was a huge feat at the time. In Nature Methods, they got the DOME recommendations published, which are recommendations and guidelines for machine learning publishing best practices, specifically on supervised machine learning validation in biology. And I've also linked there, if you're interested, the fair sharing entry for this guideline and best practice. DOME in itself, what is it? In actuality, well, it's an acronym for 4 different areas of machine learning, which should be disclosed when you're publishing. So there's data, optimization, model, and evaluation. And these 4 different areas should all be disclosed, and the different subfields in your publication when you're describing machine learning. So for example, on the data side, if you're publishing, have you correctly disclosed the data splits into test and training to avoid data leakage? For example, have you disclosed the optimization algorithm that you're using? Is it a convolutional neural network? Is it a support vector machine? Have you, on the model aspect, linked out to the software availability of the model to ensure that people can reuse and actually explore the model and check its validity? And on the evaluation side, for example, has there been a comparison of the machine learning methods against other previous attempts at this area using similar data sets or the same data sets and so on? DOME then has been recently supported by for its implementation with the DOME registry. So these guidelines then that you'd be applying to your machine learning paper, you can actually disclose how compliant you've been with the DOME recommendations with the DOME registry, which is a database of annotations on machine learning methods publications. So this registry allows you to produce an additional supporting entry, which goes alongside your manuscript and clearly sets out the different fields of the DOME areas and how compliant you've been to them, and provides those specific data and information. Today, we have over 200 entries in the registry by over 117 users. For the DOME registry, how it all looks. So you can see at the top left, you have the index, which shows just the different sections of an entry. So firstly, you have the publication metadata, and then you have the 4 different DOME areas: dataset, optimization, model, and evaluation. And on a specific entry, for example, here I've opened on the optimization tab, you can disclose the optimization algorithm, where here this user and their publication, they disclosed that their publication was focused on a convolutional neural network, CNN. And all of this, depending on how compliant you've been with your disclosures, you get a scoring then at the end, which shows how well compliant you've been with the DOME guidelines and applications with your machine learning methods and in your publication. It's a rough estimate, it's not the best one, but the more fields that are filled, the higher your score will be in the end. But then correspondingly, if you don't have answers that you've disclosed any of these relevant areas in your publication, the score will be lower, and it helps with trustworthiness and transparency of machine learning publications. What are the incentives to actually use the Dome Registry service? Well, firstly, we're incredibly proud to share that the Dome Registry service has been adopted in the publishing pipeline of GigaScience Journal in 2024. So all new machine learning methods papers must now complete a Dome Registry entry before they can get published. So the incentive there is that if you're not compliant and produce your entry, you don't get published in specific journals. Obviously, we're hoping to roll this out to further publishers to adopt this and support their machine learning methods publication pipeline to be more transparent and trustworthy and reproducible. And additionally, the Dome registry, when you make an entry, it's federated with the AP service, which will actually push proof and evidence to your ORCID profile that you've completed a Dome registry entry, be it for your own entry or if you're marking up and adding to the database on other publications of how trustworthy and transparent they are. So there's a twofold incentive to use Dome registry. The future of the Dome registry. So obviously we've been working on it and it's in production and adopted by publishers, but there's still a ways to go. So we're looking at refining the Dome registry with new features. So we're introducing tagging and filtering for search as the number of entries grow. So for different subfields of the life sciences, we're looking at introducing ontologies and updating the template so that there'll be less free text and the entries will be more cross-comparable. We're looking at improving and weighting the scoring. So certain areas might be more important to weight higher that they've been disclosed versus some others. And we're also looking towards machine learning ecosystem integration. So with metadata sources, so Croissant, which is a dataset metadata standard, and the newly released Farrell for machine learning model metadata standard. So beyond this as well, we're looking to wider AI areas and more targeted machine learning sub areas. So we could look to expand and have a model where you can disclose on the specific areas of unsupervised machine learning, or again in the NLP field, start disclosing on LLMs. With specific Dome entries in relation to areas that you should disclose on those, or even further afield to machine vision. And of course, eventually we want to expand beyond the life sciences. Machine learning and their methods are being applied in all different areas. A place like RDA is an incredible place where we could potentially start expanding upon that into the environmental field, social sciences, and beyond. And also, finally, one of the things I'm quite excited to mention that we're hoping to do, and with my PhD, is automating the Dome entry generation. So currently, it's all by hand, and you have to manually enter it. But we're looking at creating a literature triage pipeline to identify new machine learning methods papers as they're published, and then start automating the data extraction for certain fields that might be easier. For example, information on the if there's been disclosure about the data splits, test and training, and so on. Some final commentary on towards an open and fair machine learning ecosystem. So the ecosystem is very diverse. There's a lot of different components, but some of them that I'd like to highlight is there's a lot of excellent work going on in expert groups, so such as the Research Data Alliance Fair for Machine Learning Interest Group. They've been working on putting together, for example, machine learning lifecycle. Also their machine learning model metadata schema, so some excellent work there. But there's also folk like the Machine Learning Commons also working in this area. Additionally, there's a lot of components that are coming onto the scene, such as metadata standards for data sets or for models. So the Croissant one for data sets, and for models, the machine learning for ML one. But then there's also a huge diversity in the ecosystem between registries and data sets where further standardization work could happen. So at the database domain level, or at the more generous level, so Zenodo, or at the machine learning specific but non-domain specific ones such as Kaggle. And then there's also model sharing registries where they're domain specific, such as the AI for Life Bioimage Zoo or the Hugging Face, where they're more agnostic. And in this space, I'm just highlighting that before creating any new components for this ecosystem, look to consider interoperability, modularity, and reuse, and this will help collaboration for better machine learning services for all and reduce redundancies and costs. If you're looking to adopt Dome, so for researchers, we have a couple of links here. Please do go onto the service and try the registry entry for yourself, your own work or someone else's machine learning paper, and see how compliant it is with the standards. We have a simple tutorial as well and a digital leaflet. And if you are a publisher or know some publishers who might be interested in this, please do reach out, and we have our digital leaflet there as well linked. Some very quick acknowledgements just to my supervisor, Professor Silvio Tisato, and some members of my group, Alex Monzon and Omar Tafi, who've been doing a huge amount of work getting the Dome registry in place, and then Fotis Simopoulos, who also has been working quite closely on the Dome registry service, and of course the Elixir Machine Learning Focus Group members and experts. Thank you very much. And for the slide availability, I have a QR link there.